This is the friction practice problems, and I'm going to solve problem number 7. So Karen pushes on the handle of her lawnmower with a force of 30 pounds at an angle of 24 degrees below the horizontal. If the mower weighs 45 pounds and moves at constant speed, what is the coefficient of friction? So I'm going to represent the lawnmower as a box, and this is the grass, and this is the handle with the force that she is applying downward, a force of 30 pounds that is making 24 degrees with the horizontal. The mower weighs 45 pounds. So it's a force straight down. So now what we're gonna do is complete the free body diagram. So here we have a normal force, Fn, that is perpendicular or normal from the contact surface. We have, we need to break down this force that is not aligned with the horizontal and vertical grid. So from the tip of this vector, I'm draw a very fine line to guide me on how to draw the component of this vector. So from the tip of this vector, I draw another fine line here. I close this rectangle. So now I can draw the components. So that I'm going to call Fx, and these will be my Fy. But since I'm going to be working with this right triangle, I'm going to bring this Fy here following the tip to tail vector. So this is my Fy. So this is my triangle that I'm gonna highlight because it's gonna be handy on how to calculate the components. So to complete this free body diagram, I need to determine the direction of the friction force. So since the mower is being pushed in this direction, so the friction force is the opposite, in opposite direction. So I complete my free body diagram. So understand that the force that is actually pushing the mower is our Fx. So that will be our applied force. I could move this vector to this place because that's the beauty about working with vectors, that we can move vectors around. But I'm gonna leave there because I want to calculate the components. So to find the components, I always use sine and cosine. So here we have Fx, and here you have Fy. And I'm using the abbreviation acronym SOCA. So sine and cosine. And then I have to ask a question, what is Fx for this angle? Is adjacent, so I'm going to use cosine. So cosine of 24 is the adjacent over hypotenuse, which is 30 pounds. So my Fx is 30 times cosine of 24. So let me set up Fy as well. So Fy is the opposite of 24, so it will be sine of 24 is the opposite over hypotenuse, which is 30. So my Fy is 30 sine of 24. So to calculate these values using this calculator, I just type as is showing. Make sure that you are on degrees. So 30 times cosine of 24 is 27.4 pounds, because that's the unit that we are working. So my Fy is 30 times sine of 24, which is 12.2. So 12.2 pounds. So I'm gonna keep these handy because I'm gonna need when I set up my equations. So first, the free body diagram. Second, find the components of this vector. Third, you are going to use the equilibrium equation, which states that the sum of forces up is equal to the sum of forces down. The sum of forces to the left is equal to the sum of forces to the right. Now, I'm using these because the problem states that the lawnmower is moving at constant speed. So that's why I can use this equation. Okay, so now what I'm gonna do is I'm gonna write both equations. So the first one states that the sum of forces up. So I have up here, I have to look in this direction. So I have Fn, which is up. So Fn, normal force, is equal to the sum of forces down. So I have Fy and I have 45. So Fy plus 45. Now, forces to the right is equal to forces to the left. I just have here my Ff and I have here my Fx. So I can state that Ff is equal Fx. So I have my Fx, which is this value right here. I have my Fy, which is this value right here. So I can calculate, my Fn, which is 12.2 plus 45. So that will give me 57.2 pounds. So that's my Fn. And my Ff is 27.4 pounds. Okay, so now I have those two values, this and this. So it's always good to stop the problem and ask actually what is the problem is asking. So the problem is asking the coefficient of friction. So we know by our triangle formula for friction, coefficient of friction and normal force, that mu, the coefficient of friction, is the friction force over normal force. So we have the friction force is 27.4 pounds and our normal force is 57.2 pounds. You cancel those units and our mu is 27.4 divided by 57.2 is 0.479. So I can round to 0.48. And that's my final answer. That's the coefficient of friction.